So a few facts about Park House. It's a completely mixed-use scheme, houses retail, residential and commercial. It's circa 500,000 square feet, 100 retail, 100 residential, 200 office, and if anyone's doing the maths, the other 100 is in circulation space and various other things. There are 11 notional retail units, which has now been split down into 8 due to good letting. 7 office floors and 39 high finished apartments. Key dates: we started in 2004, hence labour of love, and I was slightly less grey haired when we started. We got planning permission in 2006. We started on site in 2008, but then, unfortunately, as everyone knows, the industry stopped for a period of time. We then changed procurement route and recommenced in 2010. And completion dates: we sectionally hand over retail in June, the office went in September, and the residential and cladding goes in approximately about 2 weeks, so you can understand that the contractor isn't really very happy that I'm out here talking about it. So, big headlines worth talking about Park House. Park House is the largest development in Mayfair in 60 years, something worth noting. Park House is a game changer for office accommodation in the West End. There is nothing like it, as you'll see, and Park House is London's most talked about retail development, primarily because there's nothing been like it in 60 years. So just to orientate you, for those that don't know London, we have the Thames at the bottom right hand corner, Hyde Park on the left, Regent's Park up at the top, and the long straight road dissecting with the A on it is Oxford Street, 2 Roman roads. I can bore you senseless about that. But Oxford Street is a world retail destination. You've got the London Eye, you've got Trafalgar Square, you've got the Tower of London, and then everyone comes to Oxford Street. Has a rich history of retail, and off retail. Off Oxford Street you also do have Mayfair with Bond Street and Regent Street. So it is a hub for retail within London. Park House sits at the western end of Oxford Street. You can see Hyde Park at the top right there, and Park Lane running parallel. That's hence the name Park House. And it sits diagonally opposite Selfridges, bottom left, and also has Primark, not a great brand, but sitting opposite, but it is Europe's highest trading store, so you can imagine the amount of footfall moving up this end of Oxford Street. The site itself was a fantastic example of 50s modernity, retail plinth with a 16-storey tower, and oddly some student accommodation at the eastern end. Very quick site analysis, and these are just stating the bleeding obvious, to be honest. Movement around the site is key. Oxford Street itself is a transport hub. It's full of buses, always is. Either end of the site, you've got the major routes in and out of Mayfair, and for people that don't like walking along Oxford Street, myself included, walk 1 street back. So what that does is it separates the block. It is a city block in its truest form, which is unusual for London. As I said, the road alignments is interesting only insofar as they are 2 Roman roads that come together. They can build them straight, but they can't line them up. But that does present itself, the site, onto Oxford Street, which brings in some interesting challenges. But because of the misalignment in terms of townscape, there are odd shifts in terms of buildings. So whatever we put back had to start to deal with those issues. And like I say, all of that tells you it's an island site. That's okay, because of this end of Oxford Street has a language of big buildings. It has Selfridges, it has Hereford House, the Thistle Hotel, but also Oxford Street acts as a buffer between Mayfair and the Great Portland Estate, either side of Oxford Street. So it allows Oxford Street to be really brash and do retail in the way that retail needs to do. So anything going back in there could sustain a larger bulk in a less fragmented form. So how do we then start to define that form, and how we start to put that back? Well, the original building went low when it needed to go high, and high when it needed to go low. So we were never going to get back up to 16 floors. Rural parks weren't about to have it. So simply trying to reintegrate this block back into the townscape, we picked up the high point of Hereford House on the right, and then just scooped it down, rising it slightly down to the smaller buildings, which is the last piece of Mayfair that just leaches onto Oxford Street. And you can see the vignette around how that form starts to suggest and heal that townscape issue. The other thing within London, one of the challenges we have are rights to light and daylight and sunlight. The rights to light issue dates back to when Dickens was around. You had to read the Sunday Times with one candle at 2 in the morning. But that does present a particular set of challenges. And what we found is by simply, we couldn't materially reduce the impact of on the surrounding buildings. So that started to shape the form, both in plan and the other section around the building. And what that started to do was play interesting games with bulk amassing. How do you make something this big look considerably smaller? It's a phrase that I use much to the annoyance of most people, but the phenomenon of the receding form, if you don't see where the end is, you don't know how big it is. That's why we do round columns instead of square ones. And the same is true here. The big image on the right-hand side, you see if you were to take the plan form and extrude it, you get to five floors before you start to hit the same bulk. We're up at 9. So you can start to see how that starts to apply. Not wishing to go too deeply into other townscape issues, in and around Westminster there's quite a classic hierarchy of base, middle, top buildings. Again, we really wanted to emphasise that. We didn't want to go too into mansard roofs because we needed, because of the 3 uses, something that brought it all together. So we used a negative detail to introduce some balconies, and you can start to see the step down that reinforced the shape that we talked earlier. But then we have the 3 uses. Park Street, top left, Park Street, great commercial address in Mayfair, seemed obvious to take the entrance off there. Residential-wise, on the top right, North Row is a lot smaller in terms of scale. Get people in off there, which leaves Oxford Street full retail. Yeah, that's what it needs to be. But what that gives us is quite a simple diagram. Effortlessly simple, very complex, as you'll see. And in terms of how it sits within the streetscape, it's not overly powerful. It's not overly dominant. Even a silver model in a wooden block, you can start to pick up all of the things that I've talked about. Ground floor is retail with the entrances coming off. Retail's key because it does set up a structural grid. It's a 12-metre grid. Oxford Street works on a 12-metre grid, which we then carry on through the building. So what you get, this is level 2, on the western end, you get a 30,000 square foot floor plate with only 6 columns. Yep, so we're talking city quality space in the West End. But also we had to start to try and define what that meant in the West End. So we got the office entrance, couldn't be a city office, didn't want to be Mayfair Boutique Hotel, so it's somewhere in between, an intimate space but with the power. And actually what this is starting to describe is where we start to get into Bentley products to help define how shapes work. So you've got dimension-driven design on the left to deal with tangential curves, and then when we get up to the roof, you create an odd shape, you've got to then define it. We start to get into GC to start putting it, and then we've got the the residential on the more intense east side. So what brings all of that together? Well, that's the cladding. It's the 5th elevation. Something that united all 3 uses, allowing each to be each to have their own character, but without being overly dominant with anything. So how do we start to define a shape that's a bit odd? One of the key drivers is obviously if you're going down the curvy building route is you have to make it buildable, which is kind of an obvious statement, but you have to find mechanisms to generate repetition. Here we have the torus. I'm not going to go into what a torus does, but what it does do is it gives you repetition along known axes. So the main shape is a series of three toruses with the roof one angling slightly, which gives us a slightly more difficult challenge later on. So how do you then soften that? Well, the corners on the vertical sides, relatively straightforward to define. They are a series of cones that are inverted. So again, we can define those quite simply. The trick or the issue for us was what we call the fillet zone. It was the transition between the side torus and the roof torus. Almost undefinable without GC, as you see. How we then set the building out became quite key as we moved on to site. Everything was set out from level 2. We set a local grid to help define the points. But we had to be very clear very quickly about what the key setting out points were, because obviously with a curvy building, you move up 100 mil, take another slice, and of course it's a different position. So we had to fix a lot of the structural elements in terms of structural slabs to help define things moving forward with the cladding. So here you see the unitized cladding system for the body, easily definable approximation of the curve. We use curved glass where we need and we think is important, so on the corners, to the transition between around the corners, so they're preformed off-site. Everything else is completely unitized. I note up here isolation for structure, and I can, if you catch me in the bar later, I'll tell you all about it. Because of the central line that runs down Oxford Street, we had to isolate the building from noise transfer up the structure. The cladding, everything generally is at level 2 except the cladding, which is level 1. So adding in yet more complexity of how we keep that because of differential movement and all of that kind of good stuff. But also you start to see the language of the vertical elements with the artwork, which sets up an interesting challenge to how we then go across the fillet. The easy way would be to change the language of the fillet and go and triangulate the whole that whole section, but it didn't fall and relate through the language that we had set up on the main side. So this is the setting out that went out with construction information, but how do we get to it? Well, this is where we get into GC. Now, John did tell me to say that whilst this does look like SS3, we did most of this on SS1 with a little bit of SS2, so I'm sure that means something. But I think it's clear. I think it's worth noting here that the curves and the arcs that were put in and imported by range could be generated by anyone. Yeah, so it didn't need any specific geometric trickery to do it. But then what we do with that information becomes interesting. So we set up a grid of points across the curves to then really test panel sizes. What's the most efficient? What's the most cost effective? We then put a surface of that grid. Then we offset the surfaces. We create a different set of points that start to help define the steel and the glass line. We put a direction on that, so parts can be generated, and that gives us a grid of panels, which we can then start to understand what the glazed elements of that would do. Now, interesting, if you take a straight line up a building, trying then to get it to go across a fillet into another torus that's going at a completely different angle, what you get is a twisting element. So it goes up and it wants to twist across. So what we've done, we had to do, is put center points in the mullions and transoms to help understand what that twist will do, because that becomes quite important. So what that gives us is a surface. Hurrah, we say. But what it does start to show is the out of plane, because if you take something that is rectilinear in its form and you put it next to something that's on a twist that's starting to dive away geometrically, you get this, what we call the ping. So you get a fantastic shark skin. You rub it one way and it's super smooth, you rub it the other way and it starts to rub up against you. But what we were able to do once we got to that point with the GC model was run a script to find out what were the out of plane. Now, Focky, who was the cladding contractor at the time, suggested that they could deal with 40 mil. Yep. So that script allowed us to identify which was outside of that 40 mil, and the red areas caused us grave concern, because whilst 95% of that form was within tolerance, those areas were out of tolerance. So that was the Focky solution, and whilst that was kind of working, interfaces were quite difficult. And one of the things that we interrogated quite deeply when Mace, the contractor, came on board, was that all of the complexity within this system was in the gasket. And that's the point where you don't want any complexity, the point you want to keep the water out. So we then went to talk to Sealy. Sealy came at it from a completely different approach and said, wonderful German way, keep it simple. Got to keep that gasket simple, put the complexity elsewhere. We do secondary steel work, we can do that. Yeah. So that then gave us another surface. Then we went, yeah, great, fantastic, got rid of the ping, we understand the steel work, but how do you then start putting complexity into the surface? Well, then there was a lot of scratching your heads, and then there was one of those wonderful moments in a meeting when we were all trying to work out how to do it. And Gert from Sealy picks up a piece of paper and went, yeah, well, if you hold two corners, it flops. So therefore, you start to get a surface that could approximate what we're looking for. But could you do it with glass? Well, why not? So actually, what Sealy did is they went back to their factory, they got a bit of glass, which is equally floppy, as it turns out, and clamped two corners, pushed the other one down, and went, eureka, it works. They didn't know it worked, but it does. So then we had to then test how far everyone wants to push it before everyone then starts to get very nervous. And they came up with a wonderful kind of L over 100 figure. I'm sure that means something to them. So what that did is, with that new set of criteria, we punched that straight back into GC, gave us a new set of points with a new criteria and the new surface and the panelization, which we went to and from with Sealy. But also we then had to script, because the L over 100, what was outside of that. And the red areas show areas that simply you couldn't take a piece of glass and push it, or they were a little nervous. So you had to warm bend those. So what you see along the fillet is 98% of it is a standard set of glass, and it's cold, bent, creased, formed, whatever you want to call it, but it is just pushing the fourth corner down, having clamped 3 of them. We also were able to analyse and use the model to help define the glass spec, because it does come over your head. There's a 16-degree rule that then you get into laminates, so then suddenly we're using double glazed units, so that's with 2 pieces of laminates that heat strengthened. So we're now trying to bend 4 pieces of glass instead of 2 pieces of glass, but it worked. So here we can see this is the steelwork in the factory, and you can start to see the top flange. Each piece is welded to take up the complexity and twist. Always amazes me, we do a lot of that, and it still comes down to a guy with a big hammer. But not content with that level of complexity, we also then had to put some blinds in. Now, blinds, like most things, want to go down straight, and they don't like twisting either. So what we ended up doing with the model on the right-hand side is looking to see how you get a cylinder to work with a difficulty to define geometric shape. And actually what we've got is a progressive rate of change in terms of the steelwork. Doesn't need to be that big structurally, just simply to take up and aesthetically take up the blind control as it comes down. So this is what it looked like going up. So this primary steelwork, the grey stuff, was done by another, and the white then went up. The net then played, and it's interesting, you can see the twists starting to form and the surface going on. That was it as of Tuesday. There's a lot of internal issues. We had to create an internal surface that didn't relate to the outer surface because of Sealy's twist, and then we had to put some chill beams up, and then we went through, because I've got the 1 minute, I'll rinse through this, a script to try and define how we get the chill beams to work. That then defined a secondary inner skin of GRP, which then went off. We could send that model off to be for molds to be made, and you can start to see all of that going in. And this is it in its finished form with the chill beams up, which run in a different geometry to the roof, complexity of brackets. And these are some of the images. So the top image is a 30,000 square foot floor plate. The main entrance, like I say, intimate spaces, tangential curves. Sublime to the ridiculous. We spent an awful lot of time with GC doing the beautiful bits, but we also then had the services to deal with. The outer forms is just rinsing through. Building in context is doing what it needs to do and what we always said it to do, but really don't underestimate how big this building is. I mean, it's 145 metres long. This image took me 10 minutes to stop laughing when I saw it, and I only saw it 3 weeks ago. But actually, in its context, it works very, very well. So what Bentley, how do we work together? Well, interestingly, and if John were here, he would be killing me at this point. And this isn't to do down the power of GC in any shape or form, but for me, it was there to refine a solution rather than giving me the answer. Yeah, we knew what the answer is, we didn't know how to define it. But the gambit of tools within the Bentley products empowers the architect to design. Yeah, because it's so powerful, there's so many different ways of doing it. Yeah, there isn't a bottleneck. We don't need the GC guide to tell us how to do it. Yeah, because we can get to it. Yeah, because the parametric tools are inherent in the basic MicroStation. I built the original 3D model because I understood geometry and I had basic tooling. Then feature solids were employed, dimension-driven design was employed, and then GC just helped us to refine that final five. Multifaceted, that approach enables varying skill sets to inform the design process. Yeah, and that allows greater ownership, and that then ultimately, hopefully, gives me a smaller team. Big complex schemes can only really be realised through a single model environment. Compatibility across consultants is key. Now, I put BIM because I thought I knew what BIM was about, and so I sat in a keynote this morning and I have absolutely no idea. But what that meant to me simply was, we did the 3D modelling of the services distribution. AKT, the structural engineers, moved to Bentley Structures to define the structures, so they had great compatibility with us. And then we whacked on some cladding and helped define. Now, based on what I heard this morning, one of the things that is key for me, and I'm probably getting on my soapbox now, but UK-based services consultants can't be left behind on this. For us, because of the procurement in the UK, in contractor design elements, it means double handling. Services consultants that I've worked for don't do 3D models. Yeah, they wait until it's procured, and then the trades then take it off. They then employ a 3D modeler, so I'm then doing everything twice. Yeah, that's got to stop. And I was so heartened looking in the keynote speeches this morning of models of valves and stuff, because I don't really want to model them anymore. GC allowed us to give comfort to the main contractor and cladding manufacturer that it was buildable and adaptable to scheme changes. Yeah, without that, tenders would go up. And we did actually find, in a slight twist of irony, Gert, who's now with Sealy, was with Schneider when we first tendered that. Almost there. And their original cost came back 50% higher than everyone else, because they, at that time, didn't think it was buildable. Here we are, 5 years later, he's now at Sealy, building the roof he didn't think was buildable because we were able to define it. And it gave him the confidence moving forward. It allows the design team to interrogate and manage interfaces. Interfaces can kill a project. And as soon as you start with curves, everyone's different, so we have to get in there and do it. Now, we don't do conferences about GC. We don't get people in to do GC. The guy that did the feature model on Park House now works for Bentley. Much to my... anyway. But what that does, it gives me confidence because actually Bentley have real people with real project skills developing real tools. Probably should go into advertising because that's a great strapline. And that is Park House.
Thank you very much, and we'll take some questions.
Hi, I'm Mark Thomas. This issue with services engineers has been bugging me for many years in the UK. Do you think there's a realistic prospect of the profession actually getting on the message and realising that they've got to address this 3D issue early on?
I think they'll ultimately be forced to, because contractors are beginning to realise that they're paying for things twice. So they get a set of ERs that they think is complete, and then it goes out to the trades who then redesign everything, so that design costs go up. Whereas we, us from an architectural point of view and from the structures point of view, we hand over a set of ERs and they're pretty much done. So, there's a lot of toing and froing in terms of, coordination, and the frustration for me is that we do it once, we set the structure, and then the trades come on board and they want to do it differently because they think it's better, and then suddenly, your builders' work holes aren't in the right place, and it becomes and as the lead consultant, it's of course all my fault. So, I think they will ultimately move that way, because I think they're slowly starting to understand the power of doing it once and doing it right.
Hello. Maybe not your focus at the moment, with only being 2 weeks off getting to the end of it, but have you got a strategy of handing over the model information for facilities management beyond the construction period?
Well, we have made our model freely available as AKT. The question isn't about us handing it over to them, it's whether they actually want it, because they don't necessarily know how to deal with that. This isn't going out. But, that's primarily the issue. The model's there. I mean, we had a slight issue with the 3D information on the services, is because it goes back to our point about consultants. The external 3D modeler went bust halfway through the process. So, of course, now we then don't have a model. We had a whole load of drawings, but they don't have a model. So, there's a resilience that isn't quite built in yet. So, the end user that we're dealing with when we're putting the O&Ms together aren't really that interested in the model. They just want a stack of stuff. And, having, sat through the keynote today, that world will definitely change. And once I actually understand what was being talked about, then hopefully I can start to inform that.
Can I just ask one question? How much will we get back from the sale of the apartments in that particular area?
Well, interestingly, from a development point of view, selling them isn't a good objective. You need to lease them, because if you sell them, you want a long lease, and if you want to develop it, it becomes difficult. The values were interestingly high, and every time I took an agent round, it went up 20%. He once described one of the penthouses that were going for about 15, 16 million as a great party flat. I don't know what that meant, but that's it. But they are looking to lease it. There's a leasing strategy that's in place, short and mid-term leases and long-term.
My name is Avneet. I believe you have used quite an amount of structural steel on the top.
Yes.
Have you also reused it at the other areas of the building?
Now, interesting question. Yes, we did. What you have structurally, and luckily I didn't put it in because I didn't have time, the basement is concrete, the cores are concrete, Then from ground to second is steel, so the retail is steel. We then isolate with pads because of the tube line. And then we mix. So the office side, the West End side, goes up as steel, and then the residential then becomes concrete, primarily to give it mass to deal with acoustic issues between apartments and east build. So we go a real hybrid, and the cores themselves are isolated at the base of the core. So we built a raft, put some pads down, built another raft, and then slip the cores up from there. So it's a real kind of mismatch of hybrid structure that's all sitting on a bunch of rubber.
So what is the maximum clear span that you got?
12 by 12.
You said you were nervous about the glass and bending it, which is understandable. I was wondering if how that amount of bending was determined. Was it because of the failure would be the breaking of the glass, or was there a long-term effect? And then secondly, has there been any issues with the glass after so long after it's been built? Are they popping out or cracking or anything like that?
No, I mean, I'll take your second question first, because that's the easier one to answer, is that we haven't experienced any issues with the bending of the glass in any shape or form. We've got other issues with the glass, but not with that. In terms of who and how we determined, I'm sure there's Sealy have a very detailed explanation. We don't know it. It's the same with the warm bent glass that we've got. Suddenly the glass world becomes very secretive when you're doing something new, and seeing Sealy produce glass as well as various other things. Their onward supply chain wouldn't necessarily let Sealy know how they were doing it. They'd give the warranty, but they wouldn't tell them how to do it. So there are a lot of meetings in glass factories, leaving cameras and phones and all sorts of reception to go and have a look. So yes, it was determined. The L over 100 is a very conservative idea of how far you can push it. How far, we don't know.
I have a small question. Were you extracting the bill of quantities from the model?
No. It's the simple answer to that. They had access to the model, but it was a little old school. So they did it, by measurement, which became very interesting because it's very difficult to measure a whole series of cuts because you don't know what's, below the 1.5 metre headline. So we spent an inordinate amount of time with the cost consultants telling them how to measure the building.
So I'll squeak one question of my own in at the end. So in your presentation, you showed a lot of generative components work on the skin of the building.
Yep.
And you had the substructure for that, and you had the structure in Bentley Structural, and you had layout drawings and plans in MicroStation. What was the working relationship between those different types of work, the 3D modeling, the drawing, and the GC parametric work?
Well, the 3D model primarily drove the two-dimensional drawings insofar as we cut the cladding and the structure to inform the two-dimensional drawing. We didn't model everything, in any full detail. So, for instance, the cores we have from the structure model, but we didn't necessarily put the dry lining around it. But we did need to control how we cut the floors because, you can't just go in and start cutting floors because, like I said, on the curve, you cut it at different heights, you get a different location. Yep, so that was very tightly monitored. But that drove the two-dimensional information. We are moving into, on newer projects coming in. It gets back to my point about empowering the architects to do it. On one of our new projects, we're moving into, a single model environment and driving everything through it. So all of the sections, plans and stuff, and that then kind of works on real time.